Students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as stationary waves. Please take down the sum. In Melday's experiment, when the string is stretched by a piece of glass, it vibrates with 7 loops. When the glass piece is completely immersed in water, it vibrates with 9 loops. Find the specific gravity of glass. Find the specific gravity of glass. Now let's assume that T1 and T2 are the tensions on the string in air and in water. We know that for Melday's experiment, we know that Tp square is constant. Hence, I can say that T1 P1 square should be equal to T2 P2 square, right? In which case, I can say that T1 we don't know, P1 square 49 is equal to T2 P2 81. So in that case, I'll get T1 upon T2 is 81 upon 49, right? Now I could say that if I do dividendo, T1 minus T2 upon T2, I want specific gravity. I'll apply theorem of equal ratio. By theorem of equal ratio, says that whatever you do in the numerator, the same thing you have to do in the denominator. That means I can say that T1 upon T1 minus T2 is 81 upon 81 minus 49. Whatever mathematical operation is done on the left hand side, same mathematical operation should be done on the right hand side. Fine. Now this is going to be nothing but 81 upon 32. Specific gravity. Specific gravity is given by the formula of weight in air upon loss of weight in water. Weight in air is nothing but T1, loss of weight in water is nothing but T1 minus T2, which we've already found out is 81 upon 32, which is nothing but 2.531. Right? So the specific gravity is going to be nothing but 2.531. Next, take on next one please. In Melday's experiment, in perpendicular position, 6 loops are obtained. In perpendicular position, 6 loops are obtained. When the mass of the string when the mass of 6 grams, not mass of string, when the mass of 6 grams, when a mass of 6 grams is put in the pan, when a mass of 6 grams is put in the pan. When the arrangement is changed to parallel position, when the arrangement is changed to parallel position, two loops are obtained. When a mass of 14.75 grams, when a mass of 14.75 grams is put in the pan. Find the mass of the pan. Find the mass of the pan. Let mass of pan equal to m0. Therefore, and T1 and T2 be tension on the string in perpendicular and parallel position. So in that case I can say that T1 will be m0 plus m1. The total tension on the string is going to be nothing but the weight of the pan plus the weight put in the pan, right? This is going to be so many grams weight. I'm not writing the thing in Newton. And T2 is going to be m0 plus m2 gram weight. That will be the tension on the string. Once you know this, now for perpendicular position, we know that frequency n is nothing but p upon 2l square root of T1 upon m, right? So in that case I can say that frequency n is, let's leave that there. And for parallel position, I could say that for parallel position n is equal to P2 upon L square root of T2 upon m, right? Now in that case I could say that, now they've said that in Mendel's arrangement, now they've said that frequency remains the change, that's the reason why the frequency remains the same, that's the reason why you put that extra weight in the pan. So since frequency remains unchanged, therefore I can say that T1 upon 2L square root of T1 upon m is equal to T2 upon 2L square root of T2 upon m, right? Now in this case L and L gets cancelled, m and m gets cancelled, so you will get P1 upon 2 into square root of T1 is P2 into square root of T2, but you know the value of T1 and T2, right? You can say that P1 upon 2, let's get rid of the square root sign, so I can say squaring. If I square both the sides, I'll get P1 square upon 4 into T1 is equal to P2 square into T2, right? Now you know the value of T1 and T2, right? You can say that P1 square upon 4 into T1. T1 can be written as m0 plus m1 is equal to P2 square into m0 plus m2. You know P1, you know m1, you know m2. The only unknown in this equation is m0. You should be able to get the value of m0. The answer for this sum should be, when you solve this, you will get this answer as m0 is 1 gram. Next, take on next one please. In Melday's experiment, In Melday's experiment, when 6 grams is added to the pan, when 6 grams is added to the pan, the number of loops obtained are 5. When 6 grams is added to the pan, the number of loops obtained are 5. When 10.5 grams is added to the pan, the number of loops obtained is 4. Find the number of loops when no weight is added to the pan. Let's assume that the weight of the pan is m0, right? That means I can therefore say that T1 will be m0 plus m1 gram weight, and T2 will be m0 plus m2 gram weight. Right? Now I can say for Melday's experiment, we know that Tp square is constant, right? So in that case I can say that Tp square, that means T1 square should be equal to T2 square, that is m0 plus m1 into P1, that's 5 square 25, is equal to T2 m0 plus m2 P2, that's 4 square, that's 16, right? So in which case you will get the value of, you know the value of m1 and m2 also. You can say that m0 plus m1, 6 into 25 is m0 plus m2, 10.5 into 16. So when you solve this, you will get the value of m0, right? Now let us assume that let P3 be equal to the number of loops when no weight is added to the pan. So in that case, as you already know that Tp square is constant, therefore I can say that T1 square should be equal to T3 square, right? T1 is m0 plus m1 into P1 square. When no weight is added to the pan, the only tension on the string will be the weight of the pan, so that will be m0 into P3 square, right? You already found out the value of m0, you should be able to get, P3 is the only unknown, you should be able to get the number of loops here. The answer here should be, answer P3 is equal to 10. You will get 10 loops when there is no weight added to the pan. Next, take our next one please. The frequency of the second overtone of a closed tube, the frequency of the second overtone of a closed tube is in unison with the third overtone of an open tube, is in unison with the third overtone of an open tube. Find the ratio of the lengths of the tube. Find the ratio of the lengths of the tube. Now, for a closed tube, fundamental frequency n is given by the formula V upon 4L1, where L1 will be the length of the tube. Now, I can say L1 is length of the closed tube. Now we are saying that for second overtone, the frequency of the second overtone, right? For second overtone, the frequency will be nothing but 2n plus 1, right? So in that case, 2n plus 1 times n, second overtone. So 2 into 2 plus 1 into n. So this is going to be 4 plus 1, 5n. So the frequency of the closed tube for second overtone will be nothing but 5V upon 4L1, right? Now for an open tube, the fundamental frequency.
So he substituted small n as 2. So there is one more small n.
This here your n is the overtone number. This overtone, this you directly write this as 2 into 2. Second overtone, that is here this n indicated the overtone number. This n indicates the fundamental frequency, right? Now for an open tube, the fundamental frequency is given by the formula n is equal to V upon 2L2, where L2 is the length of the open tube. Right? In which case, therefore, I can say that for third overtone, the frequency will be, see here I'll write this as, say, it's the frequency number, that's the overtone number, third overtone, n plus 1 into n, right? So in that case, this is going to be 4n, that is 4V upon 2L2, but they've said that the frequencies are same. The frequency of the second overtone is equal to the frequency of the third overtone, but here they've given you that n1 is equal to n2, so that means they've given you that 5V upon 4L1 is equal to 4V upon 2L2.
So,
Yeah.
so that should be 2 into 3 plus 2. Because of it's 2 into 2 plus 1.
That's for a closed tube. For an open tube it is n plus 1. For a closed tube it is 2n plus 1. Okay. So in that case here you will get V and V will get cancelled. So you could cross multiply, you will get this as 1s are, 2s are. So you will get L1 upon L2. You can say that L1 upon L2 is 5 upon 8. 5 upon 8 is L1 upon L2. L1 upon L2 is 5 upon 8. So you get this, the ratio of their lengths will be 5:8. Right? Next, take down next one please. An open tube and a closed tube are in resonance with a tuning fork. An open tube and a closed tube are in resonance with a tuning fork. What is the ratio of the length? What is the ratio of the lengths in the first overtone? An open tube and a closed tube are in resonance with a tuning fork. what is the ratio of the lengths in the first overtone? What is the ratio of the lengths in the first overtone? Now, I can say that an open tube. So I can say for an open tube, fundamental frequency. For an open tube, fundamental frequency, say N1 or N, is given by the formula V upon 2L1. Right? Fundamental frequency. Now they are saying that for which overtone? First overtone. I can say that for first overtone, here L1 is the length of the open tube. I can say for first overtone. For open tube, overtone is N plus 1. So in that case, for first overtone, the frequency will be N1, which will be 1 plus 1 times fundamental frequency. So 2N. So that's 2V by 2L1, that's going to be V by L1. That's going to be my frequency of the first overtone for an open tube. Now, for a closed tube. For a closed tube, I can say that fundamental frequency N is nothing but V upon 4L2, where L2 is the length of the closed tube, right? So in which case, therefore, I can say and 2 for first overtone frequency of an overtone for a closed tube is nothing but 2N plus 1, so that will be 2 into 1 plus 1 times fundamental frequency, that is 3N. That is 3 into V by 4L2, right? Now since the open pipe and the closed pipe are at resonance with a tuning fork, that means at resonance N1 will be equal to N2. N1 we already found out as V upon L1. N2 is 3V upon 4L2. You can find out the value of L1 upon L2 here, right? V and V will get cancelled, so you will get 4 upon 3 is L1 upon L2. That will be the ratio of the lengths of the open tube and the closed tube. Next, take down next one please. Determine the length of a pipe, open pipe. Determine the length of an open pipe which is in unison with a pipe, with a closed pipe which is in unison with a closed pipe of 20 centimeter in fundamental mode. Let's assume that L1 and L2 are the lengths of the open and the closed pipe. Now, for closed pipe, fundamental frequency is given by the formula V upon 4L, right? We will call this as N1 for open pipe. Fundamental frequency is given by the formula V upon 2L. We will call this as N2. Now they have given you that they are in unison. That means they have given you that N1 is equal to N2. That means V upon 4L1 is equal to V upon 2L2. 1s are 2s are. So in that case I'll get 1 upon 2 is L1 upon L2. But they've given you the length of the closed pipe. That means they've given you L1. So therefore I can say L2 is twice L1. 2 into 20, 40 centimeters. Next, take down next one please. Calculate the fundamental frequency. Calculate the fundamental frequency of an air column enclosed in a pipe, open at both ends, enclosed in a pipe open at both ends, of length 0.2 meters. Of length 0.2 meters if the velocity of air is 340 meters per second. Straightforward, they've asked you to calculate fundamental frequency.
So,
Yes.
if the velocity
If velocity of air is 340 meters per second. If velocity of air is 340 meters per second. Fundamental frequency. They've given you that this is an open tube. Since it's an open tube, this is going to be V upon 2L. V is given, 2L is given. You can directly multiply and get the answer. The answer for this sum should be 850 Hertz. Take down next one please. The velocity of sound at room temperature. The velocity of sound at room temperature is 333 meters per second. An air column of length of length 33.3 centimeters. An air column of length 33.3 centimeters is used. Find the frequency of the fifth overtone. Find the frequency of the fifth overtone if the pipe is find the frequency of the fifth overtone if the pipe is, first part of the question, closed at one end. Second part of the question, open at both ends. Now first let's consider that the pipe is closed at one end. If the pipe is closed at one end, fundamental frequency N is nothing but V upon 4L, where L will be the length of the vibrating column. Now, in that case, for fifth overtone, the frequency is going to be given by overtone for a closed pipe is nothing but 2N plus 1. So that will be 2 into 5 plus 1 times the fundamental frequency, 11N. So 11 into V upon 4L1. You know V, you know L. You can substitute and get the answer. Next, if the pipe is open at both ends. If the pipe is open at both ends. If the pipe is open at both ends, fundamental frequency N will be V upon 2L for fifth overtone. Now for an open pipe, overtone is nothing but N plus 1. So this will be 5 plus 1 times the fundamental frequency, 6N. 6 into V upon 2L. You know V, you know L. You should be able to substitute and get the answer. Right? The answer for this sum should be, for the closed pipe, the frequency should be 2750 Hz, and for the open pipe, the frequency is going to be 3000 Hz. Next, see the next one, guys. Calculate the shortest length of the tube. Calculate the shortest length of the tube of diameter 5 centimeters, of diameter 5 centimeters, that resonates with a tuning fork of frequency, that resonates with a tuning fork of frequency, that resonates with a tuning fork of frequency 250 Hz if the tube is first part of the question, closed at one end. Second part of the question, open at both ends. And the velocity of sound in air, and the velocity of sound in air and the velocity of sound in air is 340 meters per second. Now, they've said that the frequency of the shortest length of the tube. Now, the shortest length is possible only when the tube is vibrating with fundamental frequency. I can say that the frequency of shortest length of resonance is the fundamental frequency right. Now for a closed tube, the fact that they've given you the diameter here, that means they want you to use the end correction, right? So for a closed tube, I can say that V frequency is nothing but 4N L plus 0.3D if I'm using the end correction, where N is my fundamental frequency and 0.3D is my end correction. Therefore, I can say that L plus 0.3D is V upon 4N, right? So in that case, frequency is given to me, velocity is given to me, N and V are given to me, D is given to me. I should be able to get the length. All the values are given to me, right? Next, I can say for a tube open at both ends, for a tube open at both ends with N correction, velocity is nothing but 2N L plus 0.3D, 0.6D, sorry. 2N L plus 0.6D. where n is the fundamental frequency and 0.6d is my end correction. So again I can say that L plus 0.6d is nothing but V upon 2n. Again you know the value of d, V and n, you should be able to get the length of the tube. The answer for this sum should be for open tube, it is going to be 32.5 centimeters, and for closed tube it is going to be 60. For closed tube it is 32.5 centimeter. For open tube it is going to be 65 centimeters. Fine, do we get this thing here? Right. We will stop this here for the day. Thank you very much.